In this video, which is discussion 3.1, we're going to talk about how to specifically write chemical formulas for ionic compounds. So before we talk about writing formulas, I want to just review why metals form cations and nonmetals form anions. So to start, let's look at cations. So cations are our positive ions, and remember that in order for it to be positive, it has to lose electrons, because when we look at ions, we look at the difference in electrons. You don't want to change protons because that changes the atom. We can change electrons to give it a charge. So positive ions lose electrons because it's a negative, and when you lose a negative, it becomes positive. Typically, our metals are cations because they have few valence electrons, usually 1, 2, or 3 valence electrons. And remember, you're looking at if it's closer to 0 or 8. And so since metals are typically closer to 0, they will lose electrons in order to become stable. And so our metals form cations, which means our metal ions will be positive. So now if we look at anions, our anions are the negative ions, and in order to be a negative ion, it will gain electrons, because again, electrons are negative. So you're gaining negative, it's becoming more negative. These are our nonmetals, because nonmetals usually have 5, 6, 7, or 8 valence electrons, which means those numbers are closer to 8, and nonmetals will gain electrons. So our nonmetals are the anions that are negative. Our metals are the cations, which are positive. So next, I want to look at ionic bonds, because ionic compounds are composed of ionic bonds. So an ionic bond is a bond between a metal and a nonmetal. So if I ask you what type of compound it is, you want to look for a metal. If there's a metal with a nonmetal, it's an ionic bond. And what happens in an ionic bond is anions take electrons from the cations. So if we look down at this picture, sodium is our metal, chlorine is our nonmetal. Remember, our nonmetals tend to become negative. And so chlorine is actually going to take this electron away from sodium, resulting in chlorine being negative because it's gained an electron, and sodium being positive because it's lost an electron. And the way that an ionic bond works is, imagine that the positive and the negative are like two opposite ends of magnets. And when you bring two magnets together, they attract. So we remember opposites attract, so positives and negatives attract, and that's how an ionic bond is formed. When we look at an ionic bond, the charges for the cation and the anion will add up to 0. So in this case, Na is +1, Cl is -1. Those add up to be 0 because overall we want an ionic compound to have a neutral charge. So when we look at writing chemical formulas for ionic compound, there are some steps that we want to go through. The first thing we want to do is write down both the ions and their charges and put the metal first. So we're going to write down the metal cation with its charge and the nonmetal anion with its charge. And use your periodic table to help you, because remember, on the periodic table we labeled group 1 is +1, group 2 is +2, we skipped the transition metals, boron's family is +3, and so on. And then carbon's family is +or -4, and then nitrogen's family is -3, and then we go to oxygen's family, which is -2, halogens are -1, noble gases are 0. Then we're going to use what's called the crisscross method to determine how many atoms we need in the chemical formula. And I'll show you an example of the crisscross method when we do an example. And then if you can, reduce the subscripts. So if you have a subscript of 2 and a subscript of 2, right, that could be reduced down. They're both divisible by 2, so we can reduce it down. But when working with transition metals, something that you need to make note of is that you need to make sure that you look at the Roman numeral to determine the charge of the transition metal. Because the reason that we don't write the charges for the transition metals on the periodic table, that's why we skip it, is because transition metals can have different charges. And so the Roman numerals actually tell us what the charge is. So now we're going to look at some examples. So we're going to start with lithium oxide. So if we look at our periodic table, the symbol for lithium is Li, and it's in group 1, so it forms a +1 ion, because lithium has 1 valence electron. 1 is closer to 0. So lithium loses its 1 valence electron, and when you lose a negative, it becomes positive. That's why Li is +1. Now, +1 and 1+ are the same thing. You can write it either way. And then oxide, so when we are looking at naming when we see IDE, that means that it's an anion directly from the periodic table. So this IDE means that I'm looking at ox something on the periodic table, which in this case would be oxygen. So oxygen is O2 minus because oxygen's family forms a -2 or 2- charge. Now what we can actually do is we can use the crisscross method. So for the crisscross method, you circle just the number. Don't worry about the charge, just circle the number. So I'm going to circle the 1 and I'm going to circle the 2. All right, leave the charges out, but then we crisscross. So we crisscross. This tells us how many of each atom we need. So that means we have Li, and we're going to have some subscript down here. That's what we crisscrossed down. So we're actually going to have Li2O. What this means is I need 2 lithium atoms and 1 oxygen atom. So Li2O is lithium oxide. And the reason that this crisscross method works, instead of using algebra, we're using this shortcut. Because remember, ionic compounds need to be neutral. And so we need 2 lithiums. That will make this entire lithium part +2, because each lithium is +1. We have 2 of them, so it's +2. Each oxygen is -2. So +2 - 2 equals 0. That's why we use this crisscross method. So now let's look at magnesium bromide. So magnesium, look on the periodic table, is Mg. It's in group 2, so it's Mg2+. Bromide, again, the IDE tells us that it's directly off the periodic table. So we're looking at bromine, which is Br-1. So then let's use the crisscross method. So we circle the 2, we circle the 1, and we crisscross. So the 2 goes down next to the bromine, the 1 goes down next to the magnesium. Now if you notice up above, I didn't put the 1 over here next to oxygen. Now if you really want to, you can, but if it's 1, we just leave it blank because we can count it right here. There's 1. So after using the crisscross method, we find that the formula for magnesium bromide is MgBr2. So now let's look at chromium 3 oxide. Right? The 3, III, these are our Roman numerals. These Roman numerals tell me the charge on chromium. Now chromium is a metal. Metals are cations. So what that means is this is Cr3+. And then oxide, like in number 1, represents oxygen, which is O2-. And then we use our crisscross method. So I'm going to circle the 3, I'm going to circle the 2, and we crisscross. So the 2 comes down as a subscript on chromium, the 3 comes down as a subscript on oxygen, so Cr2O3. Again, it's because we need 2 chromium atoms, 3 oxygen atoms in order to make this neutral. Now finally, let's do copper 2 sulfide. So copper 2, this tells me that Cu is 2+. Sulfide represents sulfur from the periodic table, so it's S2-. Now, let's crisscross this. The 2 comes down, the 2 comes down. That gives me Cu2S2. But notice that both of these subscripts are divisible by 2. If I divide both of these by 2, I get Cus. So this is what it means when it says reduce if possible. So we can reduce this down to just Cus. So what I want you to do is actually open up the discovery that we did in class, and there are 3 tables for number 11. I just want you to do the first 2 tables. So the first table just deals with metal, non-metal, and the second table deals with transition metals. So do those 2 tables, and then you can check them in class and see if you have any questions.